Hopefully we're getting better because it's the same thing over and over again. So what are we discussing now? 3. And then we discuss 4 on Monday. And these tests is on Tuesday. Okay, let's go over these. Oh, very good. We did all the proofs. So you guys are getting better. Anyway, so on the test on Tuesday, I'm not going to give you a proof, but see, I'm going to, you see, like, for example, number 2, C. I'm going to give you the left side of that, and then I'm going to tell you simplify that in terms of cosecant x. So it's kind of like a proof. You got to do what you have to do in a proof, except you're not going to know what that right side is, and you got to low me it until you get there. So it's not a proof, but it's like a proof. Okay, number 3, E through G. Okay, now on the test, you will have one inequality like this. Okay, how do we solve inequalities? We studied that several chapters ago. What's the procedure? Make one side 0. Except this is not 0 full, this is cosine x. So make one side 0. And then what? Factor it, and then make a number line, right? Okay, so we need to factor this. It's hard to factor when you have both sine and cosine, so what do? Change the cosine or change the sine squared. We have an identity for sine squared, it's 1 minus cosine squared. So again, you want to make it all one variable. So 2 minus 2 cosine squared x minus cosine x minus 1 is greater than 0. Put it in descending order. Negative 2 cosine squared x minus cosine x plus 1 is greater than 0. But you want the first term positive. I mean, you don't have to have it, but I want it positive because I don't want to make a mistake. So multiply both sides by negative 1 and then change the greater than to less than. And then factor it. Will it factor? It has to, otherwise you can't do the problem. So plus minus, there you go. Okay, now the only difference between, like if it were an equal sign or a greater than, like, or a less than, if it were an equal sign, then what are your answers? When is this equal to 0? When is cosine x equal to 1/2? Well, you just took this quickly. Pi over 3, 5 pi over 3. When is cosine x equal to negative 1? Pi. So if this were an equal sign, these are the answers and you're finished, right? Like today's quiz. But when you have an inequality, you put these numbers on the number line and then you got to test. So it takes a little longer. Okay, so think of a number smaller than pi over 3. And again, you only have to solve it between 0 and 2 pi, so you don't have to worry that much. What's a good number to pick here? 0, right? If you can pick a quadrantal angle, that's the easiest thing to pick, right? So if you plug in 0, cosine of 0 is 1, 2 minus 1 is positive, 1 plus 1 is positive, positive times positive is positive. And then just alternate the signs. That's got odd powers. No! That only works when you have polynomials. These are transcendental functions. Trig functions, there are no patterns. You guys understand? There's no patterns. So you have to check each region individually because there's no pattern. So again, if you don't know your trig values well, then this could take you like, I don't know, 10 minutes and you don't have 10 minutes, right? Okay, think of a number between here and here. Pi over 2. Cosine of pi over 2 is 0. 0 minus 1, negative. 0 plus 1, positive. Negative times positive is negative. Yeah, but it's alternating, Mr. Park. Can you see why this one doesn't alternate? It's impossible for this one to alternate. You know why? Because if you plug in 0 and you get positive, then when you plug in 2 pi, shouldn't you get the same result as if you plug in 0? 0 and 2 pi is the same thing, that's why, right, on the unit circle. So if you plug in 0 and get pi, you plug in 2 pi, you also better get plus. That's why, how in the world can it alternate? I'll give you a nickel if you can make it alternate. You can't. That's why you have to test each region separately. There is no pattern. Okay, what's a good number to plug in here? What's a quadrantal here? 3 pi over 2. Cosine of 3 pi over 2 is 0, so that's good. 0 minus 1 is negative. 0 plus 1 is positive. Negative is positive is negative. There's your number line. So in this problem, it's going to be like 2 points for each. You can get it correct. And we're looking for less than 0, so it's going to be here and there, and then you just write down your answer after that. So this is going to be one of the problems on the test. Solve inequality. So make one side 0, factor it, and then make a number line, just like we always do. F. Okay, what should I do? Should I distribute the sign? I think so. Because you can't do anything unless this side is 0. Some of you still go something times something is 1. So that means that's 1 and that's 1. Don't be ridiculous. Is that the only way you can get 1? 1 times 1. What about 2 times a half or 3 times a third? That's why the only time the way you can do this is this side is 0. So okay, what's the procedure for solving equations? Make one side 0. You get here, so minus 1 equals 0. And then you have to factor the sides somehow. Does this look factorable? If you can factor this right now, I'll give you 2 nickels. No, it doesn't. So what do? What's the only thing you can do? Where do I see it? Like use of body? Right there. What can I substitute for sine squared x? 1 minus. If there's nothing there, then you gotta look for something, people. You guys just go, oh, I just go write them on the board tomorrow. But you don't learn that. Oh, the ones cancel out. Now is it factorable? Yeah, now you can factor. What can I factor out from this and this? A negative cosine x. And what's left? Cosine x plus sine x equals 0. So if something times something equals 0, that means either this is 0 or that is 0. So what makes this 0? Cosine of what is 0? Come on. Pi over 2, 3 pi over 2. Okay, now here, what makes this one 0 though? Where's the perfect? I never saw that's the one before. Yeah, but you just think about it. When is cosine plus sine equal to 0? When cosine equals negative sine. Now just think about it. Where on the unit circle is the sine and the cosine going to be opposites? Isn't it going to be 3 pi over 4 and 7 pi over 4? Because cosine is negative root 2 over 2, but sine is positive root 2 over 2, right? And then same thing over here. 1 is positive, 1 is negative. So it's 3 pi over 4, 7 pi over 4. Now if you don't like that explanation, then here. How about divide both sides by sine? Divide both sides by sine. Go. Divide both sides by sine. Okay, I'll do it. Cotangent x equal negative 1. Where is cotangent x equal negative 1? 3 pi over 4, 7 pi over 4. Okay, if you don't like that explanation, divide both sides by cosine. 1 equal negative tangent x, which means tangent x equals negative 1. Where would that be? 3 pi over 4, 7 pi over 4. So okay, and then finally G. Okay, several things you can do. You want to change everything to tangent? Or change, in other words, what can I substitute for secant squared? Tangent squared plus 1, right? And then square that. Or substitute secant squared minus 1 for that. Or change everything to sines and cosines. What do you guys want to do? Okay, change this to secant squared minus 1. That would be my choice. That's only assuming if you know the identity, right? Now, you guys know if you use the wrong identity, that's fatal error. Yeah. So, 3 secant to the 4 is equal to 10 secant squared minus 10 plus 2. It has quadratic form, so you make one side 0. Minus 10 secant squared, that's minus 8, so it'll be plus 8 then, right? Okay, so 3 secant squared and secant squared. And see, let's see, 4 and 2, or 2 and 4. This one is 2 and that one's 4, right? Because minus minus. Minus 6 and minus 4 will give you minus 10. So setting each factor equal to 0, secant squared x is equal to 4/3 and 2. And then square root both sides. Secant x equals plus or minus 2 over root 3 plus or minus root 2. And again, if you don't like secant, just reciprocatize both sides. Cosine x equals plus or minus root 3 over 2. Flip down over, you plus or minus 1 over root 2, right? And these are all numbers you're supposed to know, yeah. If it doesn't come out to a number you're supposed to know, like root 3 over 2, 1 over root 2, 1/2, 0 or 1, you did something wrong. It has to come out to things you know, because there's no calculator. Of course, if I let you use the calculator on the test, everybody better get it right, right? How do you solve any equation on your calculator? Make one side 0, graph it, and wherever it crosses the x-axis, those are your answers, right? Except some of you still have your calculator in degree mode, that's pain. That's why you probably have a hard time. Okay, we're done then. So look, lastly, look at the format of the thing. It's the same. Everyone is the same, because that's what the test is going to look like, people. You're going to have some graphing problems. You're going to have one or two proof-like things. You're going to have a whole bunch of equations to solve. Yeah, and that's pretty much that. You got to get good at solving equations. And one inequality. Okay, we're done. You got 7 minutes left. Study your vocabulary.